Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of areas of region, which is nothing but the application of the concepts of integration. So if I talk about the question here, the question tells us to find the area of the region which is enclosed between the curve y equal to x cube and its tangent at the point minus 1 comma minus 1. So we need to find the area of the region which is enclosed between the curve and its tangent. And if I talk about the options that are given to us here, the options are 23 by 4. The second option given to us is 19 by 4. Third option given to us is 27 by 4. And the last option given to us here is 31 by 4. So we need to figure out which one of the four options is the area of the region between the curve and its tangent. So first of all, for the tangent, let's find the equation of that line. So we'll understand what is the area of the region that we need to find out here. So for the tangent, if I try to find the equation of that line, first of all, if I try to find the slope of this line, to find the slope, I know it is tangent to this curve y equal to x cube. So if I differentiate this curve's equation with respect to x, I get dy by dx. It is nothing but 3x squared. Now we know that this line is tangent to the curve at point minus 1, minus 1. So if I put the point coordinates as minus 1, minus 1, I have my x coordinate as minus 1. So if I substitute here x as minus 1, I get my slope turning out to become dy by dx at minus 1, minus 1 is 3 into minus 1 square, which is 1. So I get the slope of this line as 3. Now if I want to find the equation of the line or equation of tangent, it is given by y minus y1 is equal to m x minus x1, where m we already know now, that is the slope of the line, that is given by 3, and x1 y1 are your coordinates. So here if you see, they are the coordinates minus 1, minus 1. So if I substitute minus 1 and x minus 1. So I have the equation of line, that is y plus 1 is 3, x plus 1. So I get y plus 1 is 3x plus 3. And with that I get y is 3x plus 2. So I get the equation of the tangent here, that it is y equal to 3x plus 2. Now, if I try to show it to you here, I have my y-axis, I have my x-axis here. My coordinates are minus 1 here somewhere. And this is my equation of the line. The slope is 3 here. So if I draw this, let's say this is your tangent line, y equal to 3x plus 2. And you also have a curve here, which is y equal to x cube. So if I draw that curve, let's say your curve looks like this. It's tangent at this point. So this is your curve. Now we know already that one point of intersection of the curve and the line is minus 1, minus 1. Now we also need to find out the other point of intersection. So we can apply the application of integration to find the area of the region enclosed between the two curves. So let's do that. Let's find the other point also. Now we know when we have to find the point of intersection of the curve y equal to x cube and y equal to 3x plus 2, I can actually equate both of them as it is, and I will get the points of x from there. So let's have those two equations, y equal to x cube and y equal to 3x plus 2. Since both of the left hand sides are equal, I can equate the right hand sides as well. So you get x cube as 3x plus 2. From that you get x cube minus 3x minus 2 is equal to 0. Now if I try to solve this cubic equation which we have got, so let's substitute some values for x first. So if I substitute x as 1, I get 1 cube, which is 1, minus 3 minus 2 minus 2, which is not equal to 0. So 1 is not a factor here. Let's put x as 0 and check. So 0 minus 0, minus 2. That is also not equal to 0. So 0 is also not the factor here. If I put, let's say, minus 1, or instead let's put x as 2. So if I try with x as 2 first, I get 2 cube 8 minus 3 into 2 6 minus 2. I get that as equal to 0. So I understand x equal to 2 is the solution of this equation. That is one root out of the 3. So I get that the factor is x minus 2. So whenever we have our solution, we just take the solution on the left hand side and we get the factor. So I get x minus 2 is a factor of this cubic equation, x cube minus 3x minus 2. Now if I try to solve that cubic equation by the method of division to get my remaining factors, x cube plus 0x square, because there is no term for x square, minus 3x minus 2. Here you have x minus 2. If I divide the first parts of x cube upon x, that is x square. So I write that as x square multiplied with x minus 2, you get that as x cube minus 2x square. So x cube minus 2x square. This is subtracted, this is added now. Signs change. So this gets cancelled. You get 2x square minus 3x minus 2. Now further, if I try to solve this, again if I divide the first parts, sorry, 2x square divided by x and x cancels, you have 2x here, so plus 2x. 2x if I multiply with x minus 2, I again get 2x square minus 2 into 2, which is 4x. Again changing the signs, this gets cancelled. You get minus 3x plus 4x, which is x minus 2. Now x minus 2 divided by x minus 2, we already know it is 1, so you get the remainder as 0. Subtracting x minus 2, you get the remainder as 0. And with that, you get the quotient as x square plus 2x plus 1. So now I know x cube minus 3x minus 2, I can write that as x minus 2 into x square plus 2x plus 1. Now when I have a square plus 2ab plus b square here, I can write that in the form of expansion as x plus 1 the whole square. Now when I have x plus 1 the whole square here, I can equate that x cube minus 3x minus 2 equal to 0. So I get x minus 2 into x plus 1 the whole square is equal to 0. Now, if some of you haven't understood how I got this, this is by using the idea of a square plus 2ab plus b square, which is the expansion of a plus b the whole square. Yeah, so that is how I got that. Now if I equate it with 0, I get the values of x. 1 is 2. Here I get x plus 1 the whole square. So I get two values of x from this, that is minus 1 and minus 1. Because I get x plus 1 into x plus 1 is equal to 0. So x becomes minus 1 and minus 1. With that, we get three values of x, that is 2, minus 1. So I get the understanding. We already know minus 1 was 1 point that we had here. So there's no point in getting minus 1, but we have our other coordinate now for x, that is 2. So this second point is having the x coordinate 2. And if I put x as 2, I get y here. So if I put the x as 2 in the equation of line or curve, anything. So if I put it in equation of line, I have y as 8. So I get my second coordinate as well for this point of intersection between the curve and the line. Now, once I have this, what I understand from here is, if I take a vertical strip, my values of x go from minus 1 to 2, and or instead of vertical strip, if I take a horizontal strip, so I can talk about it in terms of x. So if I take a horizontal strip, I get the understanding that my coordinates of x goes from minus 1 to 2, and my region is between the line. So first you will have equation of line minus the equation of curve. So if I just solve that now, taking integrals here, So area of the region, we know here it's x1 to x2 and y dx. So if I take that, you have -1 to 2. Here you have the y as 3x plus 2 minus x cube dx. So if you integrate this, you get 3x square by 2 plus 2x minus x raised to 4 by 4. And the limits are -1 to 2. So if I solve this further, I get this as 3 by 2 into 2 square plus 2 into 2 minus x raised to 4, that is 2 raised to 4 upon 4, minus you have that as 3 by 2 minus 1 square plus 2 into -1 minus -1 raised to 4 upon 4. So you get this as 3 by 2 into 4, so 12 by 2, 6 plus 4 minus 16 by 4 is 4, minus you have here as 3 by 2 minus 2 minus 1 by 4. So you get 1.5 minus 2, which is minus 0.5 or minus half, minus 1. And the first part becomes 4 minus 4, 0. So 6 minus this. So you get this as 6 minus half. So if I take the same denominator here, I'll multiply by 2. So minus 2 minus 1. So you get minus 3 by 4. So you get that as 6 plus 3 by 4. That is 24 plus 3, 27 by 4. So you get the understanding here that the area of the region which is enclosed between the curve y equal to x cube and its tangent at the point -1 -1 is 27 by 4. And if you see the option that matches here with the question, it is answer C. I hope you have understood how to solve this type of questions which deals with the ideas of finding the area of the region which is enclosed between the curve and the line. So first we found the equation of that tangent using y minus y1 equal to mx minus x1. Once I got the equation of line for the region between the curve and the line, we just found out the 2 points of intersection. We already knew the first point of intersection. We equated both the equations. We got a cubic equation. We solved that cubic equation. We got the factors x minus 2 and x plus 1 the whole square. With that, we got three values of x satisfying the cubic equation, which is 2 minus 1 minus 1. Once I solved that, I got the second point of intersection, which was 2 comma 8. And then I just used the application of integrals, integral from x1 to x2 y dx, taking the horizontal strip. So once I took my horizontal strip, I understood it goes from -1 to 2 and it goes from the line to the curve. So 3x plus 2 minus x cube. So once I got that, I just solved the integral and I got the answer for the area of the region as 27 by 4, which I think matches with option C. So that is the answer for the question given to us. I hope you have understood how to solve this type of questions. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on 11th, 12th as well as JEE mains. So stay tuned for more videos to roll out. Also, do like, share and subscribe to my channel. Do share these videos with your friends also who are involved in the preparation of the questions on JEE. So they can also take the benefit from these questions which we are solving on everyday basis. Thank you.